Yeah, the screen is visible.
Okay, thank you. Maybe before we start, can the participants confirm if they have experience with Python and Anaconda? You can write in chat if you want. If you already have the Anaconda installed, then it's okay. You can use the one that you have. If you don't have, then you should maybe right away, maybe later, I don't know. I'm letting you decide. Google Anaconda download, and then you should download Anaconda because I will be using it today. If you want, you can still type in the chat if you have the experience. Okay, so I do recommend if you don't have the Anaconda downloaded to start to download it now and then install it. The installation is pretty easy. Just next finish, and once it is finished, you should open Anaconda prompt. Just type in the Anaconda prompt within the search bar in Windows, and the Anaconda prompt will open. I will be using this today already. We will also need an Microsoft MPI, but I will show you how to install that later, and I will install it together with you. This, I think, you can manage and you can install it alone. Okay, so far you might have experience in writing sequential codes. You write some code in some editor, it doesn't matter, and then you run that code. Once you run that code, it becomes a process. So let this be a sketch of a process, and process is performing usually a single task or multiple tasks. Sometimes within this process, you have something that is called threads. So let's say this is a single process, but sometime within that process, threads are usually marked like this. You can have threads which are sometimes called lightweight processes. These can perform at the same time, and it is called concurrent programming. And these threads, they have some type of shared memory, which belongs to the main process. And they can have some form of their local memory within them. And you can also use some types of functions to exchange the data between threads, to synchronize these threads, and in such a way that they solve your problem. So this is sequential and concurrent programming. Here we will try to write code in such a way that multiple processes are run. So let's say 2. This is process 0. And here we have process 1 and process 2. And we'll write such programs that once we run multiple processes, they will perform one or a few tasks together by synchronizing and communicating between each other. This type of programming is usually done in an environments with multiple processors. Your computer, my computer, has one single processor with multiple cores. But this type of parallel programming is usually done in environments, in computing clusters, where you have multiple computers connected with multiple processes, and you can run your programs in such a way that you run, for example, 100 processes and so on, and they can work on different processors within their environment. Of course, you can run parallel programming on your computer too. You will create multiple processes, but they will use one of your cores to execute, one of your cores within the processor. You usually do not have control which one. That is the task performed by your operating system. So you will run multiple processes, and they will communicate between each other. But the execution itself and the scheduling is performed within the operating system. The type of communication that we will be using is called the MPI. That is short for Message Passing Interface. This is M. And this message passing interface is a standard for communication between processes. So there can be a type of communication between threads within a single process, and type of communication between multiple processes that are running in parallel. You can combine these two approaches if you want. You can have multiple processes and each of these processes or some of these processes can have threads inside, and these threads are called lightweight processes because they share memory of the main process and they can have some their local memory. Each of processes, of course, have their own memory, separated memory. So we will have to take into account this information that processes have their own memory when we are solving the problems. So maybe before we do all of this parallel programming, we will perform some kind of simple sequential programming just to remind you, or maybe if you haven't worked with Python before, maybe to learn something new. So we will start from the beginning, from very simple things, and then we will try to build up to more complicated things and to arrive to this level where we can write code in such a way that the multiple processes are run. So I will be using Anaconda now. If you downloaded it and installed it, great. If not, maybe you can follow and repeat this later. I will change the colors of my terminal, maybe like this. I think it's easier for you to see if it's like this. Here I will create a new environment, and I recommend you do the same in your code. So conda create minus name, and then here we can have the title, the name of environment. I will call it HPC, short for high performance computing. Can you see the commands clearly enough, or should I zoom in? Can you see this text clearly enough? Maybe some.
Yes, we can.
Oh, great. If needed, I can zoom in. So I typed conda create minus or dash name HPC, and conda created a new environment for me. To activate this environment, I should type in conda activate. And then you can see here that the name changed from base to HPC. Then I recommend we install pip. That pip is installed conda install pip. You accept, type yes, and it will install. We will be using NumPy. So you can install NumPy using pip install NumPy. I'm not sure if this should be read pip or pipe, but whatever. Then we will also install MPI 4Pi. That's for message passing interface. And we will need this maybe not right away today, but for sure we will need it tomorrow. This MPI 4Pi is just a library for Python. It is if you don't install MPI on your computer itself, you will not be able to run the MPI program in such a way that you have multiple processes. So the next thing that you should do is you should search for MPI Microsoft and download that. I think the version is not important, so you can use this 10. Here you can choose whichever. I will choose the exe file. And then the installation is pretty simple. Next, finish. It shouldn't take long. Okay. I'll delete this file. Okay. And the way to check if it worked is to type in the MPI exec. And if you get a list like this, then it's okay. If you get the list, the MPI exec is not found, then something went wrong. We will be using this MPI exec to run a multiple processing program, but for now, okay, let's stick for a single process programs or sequential programs. Let's start from the very beginning. We can just print something on the screen using a print command, and let's say hello world. Okay, we see the hello world here. We typed in the command and its result is here. I will exit the terminal and I will write code in any editor. You can use any editor you like. Maybe Spider or I don't know which one you prefer. I don't have Spider here. I can install it. You can even type code in Notepad or anything, especially if it is really simple. But we will use the, okay, maybe I will not be using Spider, but we will use the command line to run the programs, especially when running the multiple processes. So I will open, I don't know, let's say Notepad because it's faster for me. And then here, we'll type the same program, hello world. So, nothing fancy. And I will save it onto my desktop. This program. Type of file, it should be Python. So it should have the extension .py. Okay, as you can see, it recognizes it. Then here I should go to my desktop because I'm not. I'm currently in this part. C users del. This is saved under C users del desktop. So I will change the directory. This command cd is to change the directory within the terminal. Okay, and I am now at the desktop, and here is my file. To run this file, I should type Python and then the name of file, and I will see the result, the output into the terminal. Okay. So we tried this. Printing works. That's okay. And of course, this is a sequential program. We can run this program multiple times, and we can run this program at the same time. And it will execute in parallel, but this program will finish, I mean, all of the instances of this program will finish totally independently. There is no communication between processes in this case. Later, we will learn how to code in such a way that our processes communicate. So this is just a standard sequential programming. You can import things in Python. I think who already has some experience knows this. This sys is shortened for operating system. For system, sorry. And here, let's try this. Import sys, and we can print this sorry, argv. This argv are just the arguments of this program, and the arguments should be passed through the command line. So we'll write something before program with following arguments. Okay, and here I need a comma. So I imported the sys, and I will need it for to access the argv, argc, and so on. Argv are values of the arguments that are being passed to our program. And once again, we'll go into the terminal. And here you can see that the only program argument that I typed in is the name of my program. Okay, so the first command is Python, and next we have word first program.py and a list of our argument consists only of program name. I can also add something. I can add, let's say, I don't know, second argument, maybe third, etc., and so on. And here you see that my first argument is the name of program, second is second argument, then we have this third, and then etc. Okay, and all of these are strings here. We have a list. When you see these brackets, then you know that this is a list. And then within list, we have the text. We know that it is text because it has these marks. Okay. Then we can work, and we will work a lot of with lists in Python. And here we will be using the NumPy, which is specialized for working with numerical values. Let's try something. So here we will create a list. That's list 1, let's say, that has numbers 1, 4, 56, it doesn't matter. We can print this list on screen. We can access the members of the list in command print. So the indices in Python start from 0. So we don't say this is a first element. We say this is a 0th element. Then this is the first one, and then this is the second one. Okay? So if we print list 1 of 0, that's the 0th element within the list. In this case, that's 1. Then we can print, let's say, first, and then second. Let's try this. So once again, in the terminal, in the Anaconda prompt, we will run program first program, and this is what we'll get. So the third line of my code printed the full list, and we can see that here. The fourth line of my code printed the 0th element within the list, and that's 1. Then we printed the first one, and that's 4. And then we printed the second one, and that's 56. Another way in which we can access the last element within our list is to use this -1. If we do this, you'll see that 56 was printed twice, once because of the 6th line, and second time because of the 8th line. Are there any questions for this part? I think no. For your projects, you will have projects within this subject, within this course. You will be expected to type code. You can use ChatGPT to help you. That's okay. But you should explain all of your lines and create, let's say, a seminar paper based on your code. Of course, it is necessary to learn at least basic form of sequential programming here, because I don't think ChatGPT will be able to write full code without any errors. That's rare. So you should be able to find error. You can type, of course, totally on your own. Sometimes when I use GPT to help me, sometimes I use more time to debug or to find the error in the code once he has written it than if I have wrote it from the beginning. So it depends. Sometimes it is good. Sometimes it can be a little bit messy. Here you can use not only -1, you can say -2, and you can get second to last. -1 is 56, -2 is 4, -3 is 1. Also, I will delete all of this. When you write list 1, and then you write these 2 dots, here is expected to put a starting index, and here an ending index. If you omit both, then Python assumes that you have put here 0 and here put the last. Okay. The last element you can get in several ways. One of which is this len of list 1. This len returns a length of this list, so the number of elements within the list. The last element will have index -1. So we can use something like this, let's say. Then we should try to print this. Okay, but I forgot one thing. This is a starting index, and this is an ending one. But Python doesn't go the full way through the last one. If you want the last one to be included, you should have the number which is by 1 larger, so without -1. And here you have 1, 4, and 56. If you remember math, writing this Python is actually something similar to writing this in mathematics. It includes 0, but it doesn't include the last number. It includes the number that is by smaller than this by 1. So you should remember that. And this pattern repeats even in function range and so on. We will reach that too. Okay, also we can write, let's say we want to print everything from first element until the third one, but not including the third one. So first element and second, okay? And here you can see that it printed 4 and 56, so one part of an array. Okay, you can omit one of these two. You can omit start, and if you omit start, it will assume 0. So here it will print everything from 0th to the second element, 0th, first, and second. In our case, that's the full list. You can omit last, and you can say, let's say, everything from first until the end. And here you can see how that works. Also, I will add here some numbers. Say 16, let's say 17. You can go everything from first to sixth, but by step 2. So when you have 3 arguments here, it's go from first until sixth, but not including 6, by a step of 2. So what do we have here? That's the 0th element, that's the first one. And we print that one, first one. Then you skipped 1, by step 2. So you come to 16, which is, this is a first one, this is a third one. So 0th, first, second, third. This is a fourth one, and we don't have a fifth one, so that's about it. Everything from 0 to 6 by 2. So first, third, fifth, and that's it. Okay. We can skip, let's say, by 3. It doesn't make a lot of sense here, but try it. Then we have the first one, and if we skip 3, we get 17. So starting, ending, and step. Okay. Here is an example of list that contains variables of different type. So this is like a numerical value, then. This is like a Boolean value, true or false. Then we have none, non-existing. Then we have a list within a list. This is 0th element, first, second, and third element is a list. And fourth element is text or string. And we can access all of this individually. We can try this. Okay, this is called an example. So let's say we want to print, this is 0, first, second, third element. We can print third. Sorry, there is an error. Let's see. And my third element is actually a list itself that contains a word and a number. If I want to access the word within this list, then I should type in 0, because that's the 0th element within this element. Okay. So that's just a word. And what is special about text is that this also can be seen as a list. So maybe I'll try something like this. And we only get the first letter. So once you have the text, it's actually text is a list of characters. So this is the 0th character is W, then O is first, R is second, and V is third. To access, let's say that the last character, we can go like this, and then we have D, or we can say like this. In both cases, we get the letter D. Okay. Just let me check. Okay. This is how we can concatenate or merge two lists. If we have plus between the lists, it will merge the list together. So if we have one list that has 2 elements, 45 and 2, and we have another list that only has 3, if we add them together, we get this third list that has 45, 2, and 3. Okay. What's the difference between list 1 is equal to something, and then list 2 is equal to list 1? And this. What is this copy? We'll explain. A second. So I'll print all of the lists on screen. In all of cases, we should get 1, 2, 3, 4. Let's try. Okay, that is the case. Great. But the difference is, if we print the ID, list 1, ID of list 2, and ID of list 3, we will get the same IDs for first list and third list, but different ID for a second list, which is a copy of a first one. So what is different? This 1, 2, 3, 4 is written once in memory here, and list 3 points to exactly the same memory as this list 1. So it's not new list. If we change something in list 3, it will be seen here too. List 2 is a copy. So the memory is copied in some other location. These values 1, 2, 3, and 4 are copied in another location, and they can be used separately. Okay? So lists 1 and 3 point to the same location in memory, and list 2 is a copy, another copy of these values. So you should be careful which one of these you need. Do you need a separate memory and copy the values of list 1, or can you use the same memory as this list 1 and maybe perform something with that? Okay. The append function, it adds element to the list, and we can try it. We will be using just list 1. So list 1 dot append, and let's say we want to add 5, and then print the list. Okay, we have 1, 2, 3, 4, 5. What happens if we add 5 and 6 like this? Then this will be a fourth element, but fourth element itself, it will be a list. I think you can see here. So a zeroth element, first, second, third, and fourth element is another list which contains 5 and 6. On the other hand, if we do something like this, if we use an extend function, so I'll copy this too. And then print list 1. Here's what we will get. So the extend works in a similar way in which the plus sign works. We will extend the list 1 through 1, 2, 3, 4 with a list of elements 5 and 6. So the results will be like this, where we'll have total of 6 elements, and here we have total of 5 elements. If we want to add a single value, just let's say 5, then for extend function, it should be within these brackets, so it should be a list, and in append function, it should be just like this, just 5. In extend, it should be within squared brackets. Okay, hopefully this is okay. You can use remove to remove an element for list, clear to make it empty. Be careful here. If you say remove 88 with brackets, then you will remove this element, but not this element. If you say clear, of course, you will have an empty list. So this list contains doesn't contain anything. How we can go through a list is the next thing. We're usually using for loops. And this is the command for value, let's say, in list 1. We should, for example, print that value. I will remove everything, and I will explain this deeper. So what we did here, list 1 has these elements 1, 2, 3, and 4. And then in third line, we are using a command called for. Then we can name the variable as we like and name it value. In a list, what does this do? This for loop is iterating through list one by one value, and then it is performing tasks that are written here. For example, let's say we can add 5 to the value, increase it by 5. So value becomes an old value plus 5. This is maybe strange for mathematicians, but in programming, you can say value is increased by 5. A shorter way to do this is to say value plus equal. It's the same thing. Comments in Python are written behind this sign. So this is the same as everything behind this hashtag is not regarded as command. It is just a comment within code, so it is not executed. Okay, so what should we get now? Now we should get something like this. So each of these values, but larger by 5. Another way in which we can iterate through lists is to use indices. We can say something like this. for I in range len of list 1. I will explain. Right? Len returns a number of elements within a list. A range function returns values from 0 until this value. Okay, maybe we can try it here. Let's say range 0 from 0 to 5. Those will be values 0, 1, 2, 3, 4. So 5 is not included. We can also say from 0 to 5 by a step 2. So it will be 0, 2, 4, and that's it. We can say something like this, from 10 to 5 by step -1. So it will be 10, 9, 8, 7, and 6. 5 is not included. If we omit the first value, it will assume that it is 0. So this and this is the same thing. I will delete because I like to write my code shorter. Okay, so here we have the indices. Let's say what we want. We want the element on place on this index to be larger by 5. So plus 5, and then we can print it. I will also be printing my list before after the first loop and after the second loop. Oh, sorry. I didn't want to print the value, I wanted to print this. So what you can see here is that values within my list didn't change once I used this approach, but changed when I used this approach. Why? Because here I worked directly with the values within list, and here I used value as a separate variable. I could use here something like this. I could say value is equal to list 1 of I, then value is increased by 5, and then print value. In that case, in 7th and 14th line, my list didn't change because I didn't change the value of the element at the ith place. I only changed this value, which is just a copy of this value. Okay. You can see here that the values are not changed. So if I want to change the values, I should say list 1 of I is equal to something. Maybe here I can return this 1 of I is equal to value or something, and then I will change it. But if I work with a separate variable, I will not change the values within the list. Okay. So this is like iteration. Here we have one interesting example where we have a list of elements of different types. So this is a string, this is a Boolean value, and this is non-type, non-existing. In Python, there is built-in function to tell you the type of a variable. So if we print on screen, types of each of these elements, we will get exactly what I told you. This is a class of string. This is a class of Boolean values, true or false. And this is a non-type. So this is what you will get on screen. So what I've been talking so far are regular lists. Then we should go to NumPy lists, which are lists that are specialized for working with numerical values, either whole values or decimal point values. Okay. Okay. To work with NumPy, what we should do is first import NumPy, and then it is usually convenient to name this somehow shorter. To say import NumPy, but call it NP. Okay. Import NumPy as NP. And then we can use NP as shortened for NumPy, and create an array of values from the list. So this vals variable is already a list, and then we are converting it to a NumPy list, to NumPy array. Let's do that. We can do that with list1. But first, let's import NumPy. You can import it like this. That's okay. But then in code, you should use numpy.array and then give it list1 and call it numpy array. Okay. Print it on screen. Okay, we have 1, 2, 3, 4, and here note that it is a little bit differently printed than the list. It doesn't have these commas in between. Okay, let's make this shorter. So let's use NP here, here. Here we don't have to, we can name it whatever we like. We can name it just array. Whatever. Okay. So here, when we say, let's say, all right, +5, what will happen? If you remember, when we use plus for list, it worked in such a way that it appended an element to a list. In NumPy, this is like a vector. This is like a vector of values 1, 2, 3, 5. If we add 5, then each of element itself is increased by 5. Okay? And we can even say array is equal to +5 and then print array. Okay, so we changed the array itself, the array. Okay. Similarly to how we access the elements within a list, we can access the elements in an NumPy list. We can say from seconds to sevenths by step 2. Let's just add more elements. Okay. And these are the elements 8, 10, and 12. Because each of them is increased by 5. So we have 6, 7, 8, 9, 10, 11, 12, and so on. Okay. Here we can also work with multiple dimensions. This function arrange creates a list of values between 0 and 40, but not including 40. So it's 0 until 39. And this is like a single dimension. We can try this. Yeah, and let's print it. Okay, we have a single vector or an array of all the values between 0 and 39. Okay, but we can reshape this into a two-dimensional vector or matrix by using a reshape function. Reshape function is applied to this. So we should type dot reshape, and then we should specify what number of rows and what number of columns we want. So if we want 5 rows with 8 columns, we'll get something like this. So this is first row or 0th row, first one, second, third, and fourth. Okay, and each of these have eight values. Okay. If we reshape like this, we actually haven't changed the structure of this variable. We just change it for printing. Okay. If we want to change the variable itself, then we should say this. Okay. We should have an equal sign between this and a variable itself. So this reshape function takes in the number of takes the size of each of dimension. So 5 for rows, 8 for columns. We can have multi-dimensional arrays too. And then rearranges this, reshapes this in such a way that it has two dimensions and not a single dimension. And we can print here. Let's print both cases. So we printed once it was a vector with a single dimension, so single dimension with values 0, 1, and so on. And here we have two dimensions, number of rows being 5 and number of elements within each row or number of columns is 8 in this case. And we have something like this. So this is a first vector, and then when we reshape the vector, we get this matrix with 5 rows with each having 8 elements. Okay. And of course, when we are working with 2D matrices or tensors, in machine learning, you will often use word tensor, because tensor can be used for vector, for matrix, for 3D matrix, and for any dimensional array, let's say. That's tensor. Tensor can also be a single value, so a scalar value, a vector value, matrix, and all the other multi-dimensional structures can be named tensor. If we want to access, let's say 9 here, what should we do here? 9 is in first row, okay, and in first column. If we want to access, let's say, I don't know, 27, that's in 0, 1, 4, 0, 1, 2, 3. So third row, and it's in 0, 1, 2, 3, third column. So we should write 3, 3. We can try it. I'll try it here. I'm sorry. So it is 27 indeed. If we want to access the 28, what we should do, that's the number in the same row, but it is next to it. So here we should have 4. So it's in third row, but it's in fourth column. So we have 28. Okay, so the next topic is dictionaries, but maybe for now, let's try to write our first program that will run in parallel, and let it be hello world program. So what should we do? So up till now, we have been writing a program and then run it. I think you already have this on the link. Someone asked if I can send the slides. Of course, I can also send you by email. Do you have the access to this, to lecture materials? Sorry, to this. You don't see what I'm showing. To this lecture materials, and then here you have the introduction to high performance computing, and then you have all the lessons. I can send you a link. Is it okay if I type it here as a message? I think you will be able to download it. Here you have more materials that we will not be able to go through all of this today, of course. And I will add more materials here, okay? More codes will be here. Here you have the installation link to the MPI. I haven't put the installation link for Anaconda, but it is simple to access it. Just type in Anaconda download. Okay, so let's try to write first parallel program and let it be hello world to see what's different. So what we should import when we are writing a parallel program, we should import MPI. MPI 4.5, and we will call it for short MPI. Okay, import MPI 4.5 as MPI. Okay, and then we'll write hello. Great. If you run it like this, Python, and then first program, it will just print hello. That's what we have been doing so far. But if we want to run multiple instances of this program, we should use MPI exec. Then -n, we specify the number of processes that we want to run, let's say 5. And then we type Python and the name of our script. And then 5 times we will see the word hello. So 5 processes have been run, and all of them did the same thing. They printed hello. Once again, the command is MPI exec, then -n to specify the number of processes. We said 5. You could specify as many as you like, but don't make it a huge number. Then the name of program that is being executed, that is Python, and then the name of script that you want to execute. What happens here is that each of our processes gets their ID. Here, the IDs will be, if we run 5 processes, processes will have IDs 0, 1, 2, 3, 4, okay? And they will use these IDs to communicate with each other. You can say your process number 4, then you say, please process number 0, can you send me this and this? Of course, in programming that won't look exactly like that, but something similar. So what we can do is we can type these IDs. We can write these IDs, but how? What we should get first is the MPI.conroll. What's this? This I am missing an N. This conv world is a communicator. Once we run multiple processes, they exist within this default communicator. We can create some of our own communicators that have some of the processes that we will be run, or all of them, but this is the default one that already exists. So once we run the processes, they're all, these 5 processes will be within this communicator world. That's why it is called world, because everyone is there. And from this variable, we can get a process run. We can say something like this, rank or ID. Let's say ID. ID is equal to, the function is called get rank. Okay, and we can also get the size, the total number of processes, which is conv get size. We can say hello, I am process with ID Može. Then we will print total number of processes is size. Oh, sorry. Since I mistyped something, but I'm not sure why. Let's import something more from future. Import print function. Okay. Oh, we should install future too. Okay. Future must data. This should be the first line. So from future, we should import a print function when working with multiple processes. But it's still as it's missing conv world. MPI for pi. Okay. Let's try the one that I have uploaded. Where's that link? So this is the code that I have already been written on another computer though. So we will try that. It's a bit different. Okay. It's important that it works. So this should be the first line. This is just to specify which Python we are using, from which environment. Maybe it will work without this future. Let's try. Let's try this. Just curious. Okay, it works even without these 2 lines. Perhaps I made some spelling error here or something like that. So no imports or no future import is needed, and that comment with first comment was not needed either. I will change this a little bit. Let's try it. Hello, I'm process number, and then let's say this. I will comment this too. I will delete it actually. Let's see if this works. Okay. Okay. The other way to access the rank is to use something is not the way I'm expecting it to be, but for now maybe it doesn't matter. What we should get is we should get unique IDs. Processes should have IDs 0, 1. They don't have to print in exact same order. I mean, their rank shouldn't determine which one prints first. So if the rank of a process is 0, it doesn't mean that it will say hello, I'm process number 0 first. Maybe process number 5 will get to print before him. That's not up to us to decide. But in any way, all of the processes should come to this line. And once they come to this line, we can call a function. It is not necessary, but we can. A function called barrier. That function will wait for all of 5 processes to come to this line, to 6th line, okay? Once we have this barrier. So we run multiple processes. Someone comes here first, someone second, and so on. But once we are at the line 6, the processes will wait for each other, and then once all of them reach this line, they will continue to the line 7. Okay. Let's try this. I will return the future. Sounds odd when I say it. Future. Just a second. Oh. Let's copy all of this. Yeah. So on your computer, hopefully, you will get these ranks in another way. On one of my other computers, I got 0, 1, but in a mixed order. Let's say first, second, fifth, but not fifth, fourth, third, and 0th. But anyway, you're getting 0 here. Our second program that we should write, I will try to fix that, and I will tell you tomorrow if something needs to be installed. Our next program should be to try to sum the values of an array with multiple processes. So we will have a list, and we want to summarize all of the values. Let's write that first sequentially. So let's say we have a list 1, and we have numbers, I don't know, 1, 2, 4, 6, 11, enough. And if you want to summarize that, I mean, we can use the built-in function for summation, which is just called sum, but we will try to write the algorithm ourselves. So at the beginning, sum is 0, and then we go through list, let's say using indices, for I in range 1 of list. So we are going 1 by 1. And then we will add to the sum is equal sum plus the value of the element in the ith place. Okay, that's one way of doing it. We will print it on the screen. Using a simple sequential programming. So we're running by typing the command python first program.py, and then we will get 24. It should be correct, right? This is 7, 18 plus 6, yes, it's 24. So, okay, our program works. To write this program in parallel, what we can do, we can run, let's say, 2 processes. And 0th process can add some of the numbers, and not full list. Let's say 0th process adds these 3 together. First process adds these 2 together, and then they merge. They obtain the full result. So first process has the summation of first 3. The second, or let's say 0th process, has the sum of these 3, and then the first process has the sum of these 2, and then let's say first process can send his result to a 0th process, and then 0th process can say, okay, the total sum is this and that. Okay. So what we are trying to do, we are having one problem, is to summarize some elements. And we can do this by a single program that sums all of these together in a single value. Or we can divide this and say, okay, the first process adds these 2 together, the second process adds these 2 together, and then they communicate and they get the final result. Which of these 2 will be more efficient? In this case, actually, the more efficient will be sequential programming, because we have a small number of numbers, a list of 4 elements. So when we have 4 elements, that the computer can summarize 4 elements, can add them together very quickly. But if we have, let's say, 1 billion of elements, then 1/2 of billion can be summarized with one process, the other half by the second, and then we can add these 2 together. Okay, and that should be faster than running a single process to add 1 billion of numbers together. Okay. Maybe if we have 4 billion numbers, it is a smart idea to run 4 processes, and each of them can summarize 1 billion, and then we add these 4 values together. Okay, so we will start. Maybe we will not finish typing this program today, but that's okay. what should we think about here? What more should we think about here? When you're trying to parallelize to write a program that will create multiple processes, you should think if the process can be done independently. For example, you can summarize these first two values totally independently of summarizing these two values. So this can be run at the same time, right? So that's important. If these two operations cannot be run at the same time, then you cannot do this at the same time. You have to do this sequentially. Some parts of your program can be written sequentially. The other parts can be written in parallel. That's okay too. What's the second thing that you should note? The second thing that you should note is that processes will communicate with each other in order to acquire the final result. So each of the processes has, let's say, one half of, or doesn't matter, some part of the result. To get the final result, you can add these values together and then maybe print on just one of the processes. Maybe you shouldn't print on both. There is no need to print the final result more than once. So these are the two major things. One is what can be done in parallel, what can be done at the same time. So that's the first thing, or what can be done independently. And then the second thing, where should processes where and when should processes communicate? And there is one more, which I omitted, and that is the data division. You can, let's say you have two processes and you have 4 numbers. You can divide them in such a way that the first process adds these two together, and second process adds these two together. And this is called domain decomposition, okay? Because we are creating almost equal parts of input array and dividing them by the number of processes. Why I said equal almost? Because if we have, let's say, one more number, say 3, then this will not be divisible by 2, right? We will have 5 elements, so one should do with 2 elements, and the other should be work with 3 elements. Doesn't matter which one. So this is called domain decomposition, where we divide values like this. There are other types of decomposition, and we will actually implement the first program with the other type. And one of the other types is cyclic decomposition. So domain decomposition and cyclic. For now, what is cyclic decomposition? If we have an array of elements, 1, 2, 3, 4, 5, and let's say we have 2 processes, and we can do something like this. Process 0 uses this, and this. Process 1 uses 2 and 4. And what you can see here is that the processes are cycling. Process 0, process 1, process 0, process 2, process 0, and if we have, process 1 here, then process 1 again, and so on. If we have more processes, let's say 3, then we will have process 0, process 1, process 2. And again, process 0, process 1, process 2, and so on. So they are cycling. And here they are decompositioning the domain. So first part or first portion of the data goes to 0th process. Second part is going to first process. Third part is going to and so on. Okay. So in the beginning, what should we do? We should import from MPI4Py all the functions. Sorry. Oh, I know what was the mistake in my first try. I imported MPI4Py as MPI, not as. When you write the importation like this from MPI4Py, import MPI, that's like a specific module within the MPI4Py that you're importing. So if you say, let's say from NumPy import something, then you imported this something from this library. Okay. Then we're importing NumPy as here. So these are two different things. We are importing NumPy and then we are renaming it NP. Okay. The communicator is the Combrel communicator. Okay. The process rank. Okay. And the process size is size. Okay. Then let's make something like this. And let's say only the process with rank 0 has the data. Here I hard-coded the data, but maybe this data are in a file or somewhere, and then the process with rank 0 read them from a file and wrote them here. So other processes, they have their own memory, and they do not have, if we said something like this, they do not have this list. Okay. And let's say we will know in all processes in advance, we'll know how many data there are in this list. In this case, there are 5. Okay. So we should add 5 numbers, but for now, only the process 0 knows them. So it should send some portion of these numbers to someone else. To process with rank 1. Are you familiar with if command? Maybe not. What does if do? Maybe just a short explanation. So if, then you have some condition here. And then if this condition is satisfied, you're performing these tasks. If not, then you can have else. And then you're performing these tasks, some of the tasks written here. Let's say, I don't know, value is equal to 5 in the if this condition is met, or else value is, let's say, 0. Here, what we have done is we asked if we are the 0th process. We write a single code for all processes, and then we can ask whether we are 0th or someone else. Size is the total number of processes. If we run MPI exit minus n5, then we have 5 processes. The user might want to run MPI exit minus n 100. Then we have 100 processes, okay? Usually the data will be on 0th process. You don't need to load the data, the whole data, on every process, because then you're using more memory than you should, right? Like, if this is an input array, I will delete something because I drew too much. Let's say this is an input array. If we have one process and we have second process, someone has to load this data into their memory. Process 0, let's say, will load all of this. 1, 2, 3, 4. But then process 1 does not have to repeat all of this. If it will only use 3 and 4, maybe the process 0 can send to it only 3 and 4. Okay, and then process 1 will summarize that for 7, then send 7 to process 0. Process 0 will perform the addition here for 1 and 2. It will get 3. From process 1, it will acquire 7, and then it will say, okay, the total sum is 10. And it will print the result. Okay? It is not a good practice for all of the processes to have all of the data, because you're using more memory than you should. Even like this, you're using a little bit more memory than you should, right? Because you have full array here and one half here. So you're using 1/2 more memory, 1/2 of array more than you would do with sequential programming. But you're hoping to get the results faster because you have multiple processes running at once. Okay, so at the cost of using a little bit more memory, you will speed up your program or your calculation. Once again, in this particular case, you will actually slow it down because this is a set of too little data. We have only 4 values. We do not need to use parallel programming or high performance computing to summarize 4 values. We need high performance computing to summarize 4 billion values. That's a lot. Okay. So that's the first thing. The other thing, we can calculate how large of portion of the data will be at each of the processes. We will call that chunk size. And this is acquired by dividing the number of values by the number of processes. This is the number of values, and this is the number of processes. But what can happen? This number can be something like And in this case, for example, it'd be 2.5, right? If we have two processes, let's say I have two. For example, you can't have 2.5 elements. You can have either 2 or you can have either 3, right? So what you should do is you can enlarge this n by size -1. I will explain why. And then divide it by size, but like this. Let's start from here. This, when you have two division signs, not just one, but two, it returns a whole value division. So 5 divided by 3 will be 1. Okay, because 3 consists in 5 only one times. In 6, it will be 2. In 7, it will also be 2. In 8, it will also be 2. You have 2 times 3. 3 is consisted 2 times within 8, and you have the remainder of 2, right? To get the remainder, you will use this sign. For example, 8, 3, you will get value 2. Okay? Now let's go back to this. So n might not be divisible with size. When you divide a number by, let's say, 3, you can have remainder of 0. You can have remainder of 1. And you can have remainder of 2. You can't have remainder of 3 because then the number is divisible by 3. For example, if you divide 6 by 3, the remainder will be 0, right? If you divide 7 by 3, the remainder will be 1. If you divide 8 by 3, the remainder will be 2. If you divide 9 by 3, then the remainder will be 0, and so on. So the remainders can be in form 0, 1, 2 if we have division by 3. If we have division by n, then the remainders can be 0, 1, 2, all the way up until n-1. In this case, we are dividing by size, and we want the full number. So in order to get if there is a remainder, the largest possible remainder is this, size by 1. So that's why we are adding this value to n. And if our number of elements is 5 and we are dividing by 2, we will actually do this, 5 plus 1, right? Because 5 is the number of processes, to a number of elements. Size is the number of processes, and -1. So 2 minus 1 is 1. And we are dividing this by 2. So we're dividing 6 by 2, and we will get 3. You see, we will have three elements, the maximum of 3 elements for each of the processes. We can have less. So this is maximum number of elements for each of the processes. Okay. Now, each of the processes should have their own data. This is main data. It is stored in list. Maybe I should call it main data, full data or something like that. My data should consist, should have some part of main data here. Of course, we see this data, but in general case, you might not. Maybe this data will be somewhere in some file, and you will just load this data from, let's say, CSV and so on, and the user might want to change them. Okay, we can create, let's say, a chunk size of zeros, and you can do this like this with NumPy. I will explain. So NP is like shortened for NumPy. Dot zeros means that you're creating an array of zeros. How many zeros you want is the first argument. So you want chunk size of zeros in the beginning. And what are the types of these elements? This is a second argument, D type, integer. Here you can have integer, like whole numbers, or you can have, let's say, floating point numbers, or you can have double precision numbers. For now, we are sticking with whole numbers, so integers, and that's why it says int here. Okay. And then what should we do? We should send as a zeroth process to all the other processes their portion of the data. If we are process with rank 0, sorry. Also note, when you're asking whether an variable is equal to something, you should put 2 equal signs, not 1. If you put 1, then that's the then you're assigning a value of 1 to rank, a value of 0 to rank. Okay. If you're putting 2, then you're asking, is rank 0? Okay. So this and this, not the same thing. This is assign 0 to rank, and this is ask, is rank equal to 0? Okay, if we are 0th process, then we should send the data to all other processes. How we know to send them? We can do that like this. For I in range size. Now I will explain. This is a loop that goes through all of the processes, but we can, no, it's okay like this. So this will be from 0 to size -1, okay? So the 0th process, the first process, the second process, and so on, all the way until the process with number size -1. And for each of these processes, we don't know in advance if there are going to be 2 processes, right? The user might want to run with 2, maybe with 4, maybe with 5. We don't know that. So we have to write code in a general way. Go through all of the processes. That's what the line 19 says. And then we should create the indices that will be used by the ith process. So how can we do this? The 0th process, this is a 0th element, this is a first element, this is a second element, this is a third element. We'll be working with 0th element, then with second, then if with fourth, if fourth exists, and so on. The first process will work with first element, third element, and so on. So maybe if you remember, we already had something like this. This is range function, right? You can say range, and then from where you start, where you finish, and how much you skip, right? So how much will each process skip? It will skip the number of elements that is equal to number of processes. If there are two processes, then we will skip 2 elements. If there are 3, then we will skip 3. If there are 4, we'll skip 4, and so on. So here we should write size. Size is number of processes. You don't have to call this variable size. You can call it whatever you want. You can call it number of processes. But we chose size here in this program. Size. The first is where the process starts. In our code, our loop is through all of the processes, right? So we are working with ith process at the moment, right? So it should be I. And everyone goes until the end of the array. And that's the n. So the process with number I, if number is 0, starts from 0. The process of when I is equal to 1, that's the process 1, starts from 1. It goes to n, it skips size element. Process 2 goes from 2 all the way up until n, skips size elements. So we will have all of the processes like this with cycling indices. Just a second. Okay, so we will write this as okay. So we will not be using a simple range function. We will use numpy arrange. That's pretty much the same function. We can use range, but numpy arrange will create a vector, will create a numerical values. So it is a good practice to use numpy instead. Okay, and then what we should send? We should send the data with these indices from the main data. From the main data with these indices should be sent to the ith process, okay? First, we pack this into the chunk, and then we send this data to ith process. So how do we send data? We send data by using the communicator, which is like a con. Then we write dot, and then we write send. What we send is the first argument, and the second argument is the destination to whom we are sending. We are sending this to the ith process. But please note that this goes from 0 to size. If we are 0th process, we don't need to send the data to ourselves. We already have that. So we should skip. If I is 0, then we have our data. Then our chunk, then my data, we call that my data, is equal to main data to this chunk actually, to this chunk here, or main data indices or whatever. Okay. This is what we have been doing if we are 0 process. If we are not, if we are anyone else, we don't have the data, so we should ask for data. How do we ask for data? This is to send the data, and this is to receive the data. What we are receiving data in this variable, my data. That's where we are receiving, and from whom we are receiving values from the sorry, not destination, it's source. We are receiving data from the process 0. And now after this line, everyone should have their own portion of the data. And now everyone should summarize their data. That's what we'll do next. We can call this local sum, and we can use the built-in function for this because it already exists. And then we can print, and then what should we do? Then everyone has local sum. So here we divided the data. We performed the composition and divided the data among processes. Then everyone performed their summation. And what should we do now? Now we should do this part. Everyone should send their local sum to a main process, and then it should print on the screen. So everyone, if we are not zeroed process, this means not equal to, then we are doing what? We are sending the data. What we are sending, that's local sum. To whom we are sending? We are sending that to the zeroed process. That's it. We finish here. But if we are the zeroed process, what we are doing? We are receiving the local sum, but we shouldn't call it here local sum. I will explain why. Because here in local sum, we have our own sum, right? What we should do is, let's say, save this. Total sum is currently equal to this local sum. Okay? So total sum will be on the zeroed process. In the beginning, total sum is equal to local sum, or the sum of the elements that have been added together here. So if we added 1 and 2, it should be 3. And then we can use local sum or some other variable. We can use here, or you can call it in some other way. Who will be the source? Well, everyone else. How do we write everyone else when we don't know how many of there are? So we should go in a loop for I in range from first process. Why not from 0? Because we are the zeroed process. We already have our data. So we're starting from first process all the way until the last one. And one by one, we are asking for their local sum. And once we receive their local sum, we will add this to our total sum. So we will increase our total sum by a local sum. Okay, and finally, once this loop is over, here, we print the total sum, and that's the solution. Okay, so it will make sense to run this program with maybe a single process for 2, 3, 4, and 5. Not more than 5 because there are only 5 numbers. Let's try this. It might not work, but we will fix it until tomorrow. Let's try like this. Oh, I have one smaller. Okay. Let's print the indices. Okay, let's try with MPI exec, because we should anyway. -n, then the number of processes, let that be 1. Then we type the name of program that we are going to run, and then the first program. Okay, for some reason, it is playing stupid. Only can be converted to a scalar. But these already are integers, so that's kind of weird. Maybe I should check which Python I'm using. Should be good. Okay. Maybe let's go step back and print here our data. Check if everything is okay. Then we can print our rank. It will probably be 0 for now unknown reasons. And we should print size. Size is the number of processes. And then let's exit here just to check whether this part is okay. Okay. We run with a single process. So the chunk will be size 5, right? So we have all 5 zeros. We are the 0th process, the only existing one, and only one process exists. Okay, then let's try to run 2 processes. See what happens. Yeah. This is what happens. What it should output, if everything is okay, but I think the MPI installation was wrong in a way. I will check why. What should be the output? So here, this is not correct. We should get something like this. Just a second. So when we run 2 processes, what should we get? We should get 3 elements here. Then our rank, let's say 0. Size should be 2 because we run 2 processes here. So this should be 2. Then again, we should get 3. The ID should not be 0, it should be 1, and then 2. And these lines don't have to be printed in exact the same order. So maybe the 0th process prints these 3, then the first process prints this, then 0th process, then first process maybe prints the number 1, then we print, then the 0th process prints number 0, and then each of them prints number 2 on screen. That's the way that it should work. But it seems that my MPI installation on this computer is not okay. But I will have to check this why it's not okay. On my other computer, it worked perfectly. And then I will let you know probably tomorrow what's wrong, or I will go and present this from another computer. But this is the logic behind it. We will go once again through this tomorrow, and we will explain more this point-to-point communication, because this is what it is called when we communicate with send and receive. This is point-to-point communication. And after that, we will try to work with some more complicated forms of communication where we have the collective type of communication, such as, for example, this could be implemented much more efficiently using a broadcast communication function. Broadcast, you probably assume what it is. Broadcast means send this data to everyone. Of course, then we will have the reduction communication when we can where we are using the built-in function within MPI to perform some kind of reduction or some type of aggregation. Let's say a summation of all elements, finding the smallest values between many elements, and something like that. Anything that merges or aggregates multiple values as a single value. So that's what we'll be doing probably tomorrow. And for now, that's it from my side. Do you have any questions? Was this easy for you, difficult for you, or do you have any comments? What you should try to do is, if you haven't already, install the Anaconda and then NPI and run these two programs that are already